Go to number 9 in section 5.2. They ask you to calculate this definite integral, and this is the integral from 0 to 6 of the absolute value of 4 minus x dx. Now, I'm going to do this one by interpreting it in terms of area. Okay, I don't, and then I'll show you another way. But I'm going to do this interpreting times of area in terms of area. So I'm going to graph the function x on the interval from 0 to 6. That's what I've done here. All right. The absolute value of 4 minus x is literally just the absolute value of x function shifted 4 units to the right. Or you can just, plot points, right? When x is 0, you get the absolute value of 4, which is 4. When x is, you get 4 minus 1 is 3, absolute value of 3 is 3, and so on. When you plug in 4, you get the absolute value of 0, which is 0. When you plug in 5, 4 minus 5 is -1, but the absolute value -1 is +1. And then plug in 6, you get 2. So this height is at 2. Okay. And so when I'm integrating from 0 to 6 interpreting in terms of area, from 0 to 4, the graph is above the x-axis, so this area constitutes positive area. And that area that I've shaded in, calling that area number 1, is just a triangle. The base is 4 units, the height is 4 units, so 1/2 base times height. And then we're going to add, right, the area under the region from 4 to 6, which also is a triangle above the x-axis. So that area will be 1/2. The base here is 2 and the height is 2. 1/2, 2 times 2. So 1/2 of 16 is 8. 1/2 of 4 is 2, and is the answer. Okay. And you can check and confirm that by section 5.4, fundamental theorem of calculus part 1. So if you do 5.4, then I would stop here. If you haven't already done section 5.4, I would stop here, and that would be the way to do the problem. But if you've done 5.4, I'll show you another way, which is to use the fundamental theorem of calculus part 1. First of all, you would have to rewrite the absolute value of 4 minus x as something that we can integrate, because we don't know the antiderivative directly, because really, if you look at this, the absolute value of 4 minus x can be thought of as 2 lines, right? One is this line, which this line right here is indeed just the line, slope is -1, right? Go down 1 over 1, down 1 over 1. So that's negative, and then the y-intercept is 4. So it's -x plus 4, or write this as 4 minus x, right? This is the graph of 4 minus x, but 4 minus x would continue down this way, right? Okay. So at 4, it breaks to this line. So what's this line here? Well, here the slope is go over 1, up 1, over 1, up 1. Slope is 1. And if we move back this way, we see the y-intercept is -4. So this line is going to be x minus 4. That's the equation of that line. And basically, if you want to think about it, this line right here is the continuation of -x plus 4, or 4 minus x. But we're basically reflecting that line about the multiply this by -1. And if I multiply -x plus 4 by -1, I get positive x minus 4, right? And that's the relationship I'm showing down here. So the function f of x is 4 minus x, right? This portion, if x is less than 4. And then for values of x greater than or equal to 4, we're on this line, which is negative quantity for x, or just x minus 4. Okay, so you have to do this analysis and know. So I'm literally going to integrate 0 to 4, this function 4 minus x, and then add the integral from 4 to 6 of x minus 4. And that's what I've done down here. I've broken it up into the. Now we can do the fundamental theorem of calculus part 1, which is find the antiderivative of 4 minus x. The antiderivative of 4 is 4x. The antiderivative of x is 1/2 x squared. I'm going to evaluate that at 4, evaluate it at 0, and subtract. All right, so if I plug in 4, I get 16. Half of 4 squared is 8. Plug in 0, I get 0. Over here, I'm going to integrate. Antiderivative of x is 1/2 x squared. Again, antiderivative of 4 is 4x. So I get this is my antiderivative. Plug in 6. 36, half of 36 is 18. 4 times 6 is 24. And then plug in 4 minus this. So this is plugging in 4. I get, again, 8. 4 times 4 is 16 minus 16. So now just evaluate this. 16 minus 8 is 8. Minus 0, 8. 18 minus 24 is negative 6. 8 minus 16 is negative 8. Negative 6 minus negative 8 is 2. And so I get 8 plus 2 is 10, just like we got in the example above. Okay, so with absolute value functions, we'll do some more of these in section 5.4, but you've got to really think about the graph of the function and you know, break it up into the different segments or curves in a sense. Okay, I hope this helps with this one.